Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Math 11 content, and we're going to cover the trig ratios in a little bit of detail. So with that, let's get started. All right, so here we are. So I have trigonometric ratios. What we're going to start off with, so let's write out our Sohcahtoa. Okay, these are going to be the trig ratios that we are looking at, okay? And again, remember the sine. So let's write sine theta. This is equal to the opposite over the hypotenuse, okay? So just like this. The second ratio is going to be the cosine ratio or the cos ratio. So cos theta equals the adjacent over the hypotenuse, okay? Which is just this, adjacent over hypotenuse, okay? If you look at the tan ratio, it's the opposite over the adjacent, okay? So I'm going to write it right here. So tan theta equals opposite, okay, over the adjacent. So here I have all the ratios, okay? So we're going to start off with just like a really simple example here, okay? So let's try this triangle. So I'm going to make my triangle. Remember, when you're using the trig ratios, it does have to be a right angle triangle, okay? So put an example down here. So I'm given some values. So this is 12, 21 degrees. And I'm looking for x right here, okay? And so when you're looking for x here, okay, I have to look at the angle right across from this angle. This is the opposite side, okay? And the side that's right beside the angle, this is the adjacent side. Does everyone see that? This is the longest side of the triangle. This is the hypotenuse, okay? And we're going to write the ratio, okay? So I'm just looking at the sides here. I'm looking for the hypotenuse, okay? And I'm also given the adjacent side, okay? So I'm using the adjacent and the hypotenuse, okay? If you're looking right here, that means we're going to use the cos ratio. So how you're going to write it is just going to be cos of theta, which is 21 degrees, equals the adjacent, which is 12, over the hypotenuse, which is x. Okay, this is a really good example because you see how the variable is on the bottom. Okay, so instead of multiplying, I actually do have to divide. Okay, so what I'm going to do is take the x to the other side. So x equals 12 divided by cos of 21 degrees. Okay, does everyone see that? And we're going to just put that into our calculator. Okay, make sure your calculator is in the degrees mode. Okay, so x is equal to 12.9. Okay, so here it doesn't have any units. Okay, so let's maybe put units. So say it's centimeters. My answer should be in centimeters as well. A good way to check your answer is, again, to make sure the hypotenuse, which is the longest side, it has to be greater than each of the opposite sides given. Okay, in this case, which it is, this side is 12 centimeters, but the hypotenuse is 12.9 centimeters. Okay, all right, so let's try one more example here. Okay, so let's try this triangle. Okay, this time let's look for maybe like one of the sides here. I'm going to put x. Okay, 74 degrees. And this is 16, let's put centimeters. Okay, like that. So what you're going to do here, again, I have this angle right here. This is the side that's given to me. This is opposite. And you notice I always draw an arrow because it points to the opposite side of the angle. It depends on which angle you're looking at. This is the side that's right beside this angle. So we're going to put adjacent. I notice that the hypotenuse is not given in this question. Okay, so I don't need to use it. I'm using the opposite side and the adjacent side. If you look right here, I see it is tan. Theta is what we're going to use here. So it's going to be tan of 74 degrees equals opposite 16 over the adjacent, which is x. Okay. So one more time here, I see that the variable is given and it's on the bottom. And what you're going to do is just switch it around here, okay? So I'm just going to make an arrow. So it's going to be x equals 16 divided by tan 74. Does everyone see that? Okay. If the value of x was on top here, I would just have to multiply the two numbers. Okay, so we are doing 74 tan, or 16 divided by 74 tan, and we are getting 4.6 centimeters. Okay, and I noticed that that's the adjacent side of the triangle. Okay, if I wanted to find the hypotenuse, I could just use the Pythagorean theorem to do that. Okay, are there any questions here? Good. Okay, so let's go to the second topic here that has to do with the trig ratios. Okay, and this time we're going to have two triangles, okay? And you're going to actually solve for one of the sides using both the triangles, okay? So let's go to that. So I'm just going to write example here, and let's try this one. This is a really good question. So say this is my triangle now, okay? So it's like this. I have two triangles actually. And this is my right angle here. So let me give you some values, okay? So this is 22 degrees. This is 41. I have x. And I'm just going to put centimeters, okay? Make sure, again, you are watching the units, okay? Teachers are taking off marks all the time. So what we're going to do, okay, is we are looking for x at the end. I'm going to start off with this triangle right here. So I'm going to put 1, okay? So let's use this triangle. So this angle is 22 degrees. Right across from there, this is the opposite side, okay? And if you look really closely, I'll make another box there. This is actually the hypotenuse of this triangle, okay? Now, if you can't see that visually, I would make sure I just turn maybe your paper around so you can see that. Okay, so let's write our Sohcahtoa so everyone can see that. And you should always write this down so you don't mess up in terms of the ratios. Okay, so I am going to look for actually, so this is the opposite side. This common side here, this is the adjacent side. And that's actually the side I'm looking for, okay? I want to know what this adjacent side is so I can actually use it in terms of this triangle, okay? So what we're going to use now is the adjacent side and the hypotenuse. Okay, so adjacent, hypotenuse. So let's use the cos ratio here. So I'll write 1. So we're doing cos of 22 degrees equals the adjacent side. Let's make this y over 50 centimeters. Does everyone see that? Okay, so the adjacent side, we're just making it equal to y. Okay, and then we're plugging it into this formula. Okay, this time when you're looking for y, you notice how y is on the top here. I'm just going to multiply both of these numbers together. So cos 22 degrees times 50. Okay, and this is the value for y. So cos 22 times 50. Put it in your calculator, okay, and we are getting 46.4 centimeters. Everyone see that? Okay, that's the value for y. I'm just going to write it here. So 46.4, okay, centimeters. Because it's really important, we do have to use that, okay, when we're solving the second triangle. So let's take a look at the second triangle here. Okay, and what we're going to do is we're now going to use the 41 degrees here, okay? So right across from there, again, this is the opposite side, okay? This is still the adjacent side for the second triangle. And where the x is, okay, this is the hypotenuse. So I notice again that I don't have the opposite side. I'm just going to use the adjacent side here that I just solved for in part 1. And I'm going to use the hypotenuse because I'm looking for the x value. Does everyone see that? So one more time, cos of 41 degrees. And it equals to the adjacent side, which we solved for, so 46.4 over x, okay, which is the hypotenuse. Okay, so in this case, again, I see that the x value is on the bottom. I want to just take it to the other side. So x equals 46.4 divided by cos of 41 degrees. Okay, and we're going to just put that in our calculator. 46.4 divided by 41 cos. Make sure you're pressing the equal sign in between there. And we're getting 61.5 centimeters. Okay, does everyone see how to do that? Are there any questions? And that's actually our final answer, okay? We're looking for x here. All right, so with that, let's try one last example. Okay, so let's do it on this side right here. Okay, I'm going to draw out the triangle here. Okay, and we're going to solve for it. Okay, so let's try this one. So the triangle looks kind of similar here. Okay, it's a right angle there. Okay, the x value is going to be on the bottom. This side is 48 centimeters, 25 degrees. And on the other side, this is 59 degrees. Okay. So again, you notice whichever side or whichever triangle you're looking for in terms of the x value, I always start off with the opposite triangle. Okay. Because you notice I need to actually solve for this value. So again, we'll just make this y, okay? Right across from the 25 degrees is the opposite side. Where the y is the adjacent, okay? And the longest side here, this is the hypotenuse. So one more time, I'm going to use the adjacent side and the hypotenuse side. So let's do cos, okay, of 25 degrees. Equals, okay, the adjacent side, which is y, okay, over the hypotenuse, which is 48. Okay, just like that. You're going to just multiply them because I see the y is on the top. So y equals cos of 25 times 48. Okay, so we're going to put that into our calculator. Cos 25 times 48. We're getting 43.5 centimeters. Okay, one more time, we're doing a mental check. This is the hypotenuse, it's 48 centimeters. And the value of one of the sides of the triangle is 43.5 centimeters. So it has to be less than the hypotenuse, which it is in this case. Okay, any questions so far? Good. So we're going to go to that second triangle now. So let's write out our value here. So y is equal to 43.5 centimeters. Okay, and in the second step, we're actually going to solve for the value of x. Okay, so this time if you look at this triangle, right across from there, this is the opposite side. Okay, in the second triangle, I want to use the opposite side as well as the adjacent side. I notice that the hypotenuse is not given to me, okay, in this triangle right here. Okay, so if we look at our Sohcahtoa up here, the tan ratio is the opposite divided by the adjacent. Okay, and that's what we're going to do here. Let's use the tan. So tan theta, which is 59 degrees, okay, equals the opposite side, which is x, over the adjacent side, which is 43.5. Okay, so one more time, because the value of x here is on top, we are just going to cross multiply this. So tan 59 degrees times 43.5. Does everyone see that? Okay, when you have two triangles, I have to make sure I'm doing two steps. Okay, so we're doing tan 59, okay, times 43.5. Okay, and we are getting x equals 72.4. Okay, and this is in centimeters. Okay, so one more time, this is the final answer. So we'll box it. Okay, but you see that we do have to use both of the triangles, okay, to get our final answer, just like we did in this example as well. Okay, the only difference was I had to use the cos ratio 2 times, okay, for this triangle in that first example. Okay, all right, and so this is basically how you are using the sine, cosine, and tangent ratio to solve for basically the two-dimensional triangles that are kind of like just side by side with each other. All right. Okay, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone in the next video. Thanks, bye.